Hi students, today we are going to do section 11.2, which is solving quadratic equations using the quadratic formula. A quadratic equation, recall, is any equation that can be written in the form ax squared plus bx equals plus bx plus c equals 0. And a, b, and c are real numbers. A cannot equal 0. The quadratic formula basically tells us that the solutions for this equation, the values that x can take on, can be determined just by plugging in the coefficients and the constant terms into this formula right here. If you are wondering where the quadratic formula came from, I mean, how did we come up with this weird formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Well, the way we came up with this quadratic formula was actually by performing the completing the square with this generic quadratic over here. Right, so if you want to do that maybe for fun, try to complete the square on this guy here and see what your solution to x looks like. It'll look like this. Okay. So I have a couple examples to walk us through solving quadratic equations using the quadratic formula. I also want to point out that you can use the quadratic formula with any quadratic equation that you are given, but you need to make sure that it is in this standard form. Okay, so ax squared plus bx plus c equal to 0. And then the second thing you want to watch out for is if any of your coefficients are negative, be very careful that those negative signs get brought over here and not confused with the negative signs that are in the formula themselves. Okay. So we've got this first example, 3x squared plus 16x plus 5 equals 0. We need to identify what are a, b, and c, and then plug them into our equation. So our a is 3, our b is 16, and our c is 5. We're going to plug those pieces into the equation. And then you just work through it using PEMDAS. So make sure do this multiplication first, do this squaring first before you do any subtraction here. And then if possible, simplify that square root. And notice this fraction bar is saying that both this negative 16 is being divided by the 6 and this square root is being divided by the 6. Okay. Once you do that, you're going to get two solutions. So one is going to be the plus solution and one is going to be the minus solution. So our two answers are going to be negative 1/3 and negative 5. You can go ahead and do that simplification step there and make sure you're getting these same two answers. If you're not, please let me know or use the discussion board. Okay. Let's do another example. So these coefficients are a little trickier because they are fractional coefficients, but we are still in our standard form, right? Everything's set equal to 0. So our a is going to be 1/4, our b is a -1, and our c is a 1/2. So we'll plug all that stuff into our equation. Here is where you have your negative signs that you have to be really careful of. Because b is -1 and the formula says negative b, we've got to have negative 1. All right. And because b is a -1 and we're squaring all of b, we are squaring that -1. So it's going to become a +1 once it gets squared. Okay. Again, work this stuff out on your own. Make sure you're getting the same solution as me. This is going to be 2 plus or minus √2. So you can write that as 2 plus √2 at comma 2 minus √2 if you like. Let's do a third example. Here, x equals negative 3x squared minus 3. This is not in standard form, so do not try to take these coefficients and plug them into the quadratic formula from here. We want to put it into standard form, so we are going to add 3x squared and add 3 to both sides. We could go the other direction and subtract x, but then all our terms would be negative signs, and it's a lot easier. If you really get to choose which side you move everything to. If everything's a positive term versus everything being a negative term, it makes it easier to plug in without making mistakes. So A is 3, B is 1, C is 3. Plug those guys into our quadratic formula, and we are going to get negative 1/6 plus or minus I root 35 over 6. Okay. And keep in mind, this could be written as negative 1 plus or minus I root 35 all over 6. You really have the option to, break your fraction into multiple terms over the denominator or into all one term over the denominator. Okay. So that's using the quadratic formula. It is a lot of just plug and chug, but you have to be really careful with the negative signs and then in some of your simplification steps. So I definitely suggest you guys pause the video right now and take the time to just work through these and make sure you're getting the same answers as me. If you're not, try to identify what it is that is the mistake you're making, keeping you from getting the correct answer. Because it's probably something small, like a negative sign, and you don't want to lose points on a test for a negative sign when you know how to do this. Okay, so make sure, work through them, get these same answers. And if you can't figure out where you're going wrong, let me know. Right. So let's talk about what do these solutions mean. Eventually, this is a little more conceptual, but I just want to discuss it so you have some foundation for what it is that we're doing here. Okay, so we had these 3 equations up top in black that we were solving for x. These solutions are the values that x can take on to make those equations true. A lot of times we actually care about the solution to quadratic equations when we are looking at a quadratic function. A function, remember, is in 2 variables, and x and y change values related to each other based on the function. So if we take our equations when they're in standard form and replace the 0 with the variable y, then we actually have a quadratic function. And the solutions that we just came up with are essentially the values of x when y equals 0. Those are values that are important to us because they tell us when our quadratic function crosses the x-axis, right? When and where it crosses the x-axis. So you see how in our first example here, 3x squared plus 16x plus 5 equals 0. If I replace that 0 with a y, I now have a function, y as a function of x. This is what its graph's going to look like. And it's a little hard to see the axis here, but this is -5, this is 5. So this is the x-axis right here. And essentially this function will cross the x-axis at x is -5 and at x is -1/3. And those were the solutions to our equation when y was 0. Okay. Same thing in our second example. This is 2 plus root 2. This is 2 minus root 2. That's when this parabola crosses the x-axis. Now, in our third example, as you recall, we had complex numbers as our solutions, right? They were both complex because they had this I. This graph never crosses the x-axis. It has no x-intercept, meaning there is no real value for x when our equation equals 0. Okay, so if we have no real value, no real solutions to our quadratic equation, it means that if we look at the associated quadratic function, it will never cross the x-axis. Okay. So that's just how solving these quadratic equations are going to relate to quadratic functions and graphing later on. Another little piece that we can kind of add to this to give us some more information is this thing called the discriminant. The discriminant is b squared minus 4ac. So the discriminant is just looking at our three coefficients, and it's actually just the piece that goes inside that square root. Okay, we call that just that little portion of this little portion of the quadratic formula. That's called the discriminant, and that can give us information about the solutions to our equation. So our discriminant can be a positive number, it can be 0, or it can be a negative number. And depending on whether it's positive, 0, or negative, it tells us how many solutions we're going to have in our quadratic equation. So if it's positive, we're going to have two real solutions. And you can see that when this is a positive number, we can have a positive number under a square root, and that's still a real number. So we're going to have a plus or minus some real number. So it's going to give us two solutions, and they're going to be real numbers. And when I say distinct, it gives us two distinct real number solutions because they're going to be different from each other. One's going to be a plus, one's going to be a minus. Okay. If our discriminant is 0, so if b squared minus 4ac is 0, then this term that we are adding or subtracting becomes a 0. And that eliminates the possibility of two different solutions because we're just plus or minusing 0. So either way, you get the same thing. So when our discriminant is 0, we actually get a single real number solution to our quadratic equation. Okay, so that's nice to know. And then if our discriminant is negative, we're going to have a negative underneath the square root, which means we are not going to have real solutions. We're going to have imaginary solutions. Okay, so sometimes it's nice to just take a look at what your discriminant is going to be to get an idea of what your solutions are going to be to your quadratic equation. And when we go to quadratic functions that we're going to try to graph, the discriminant will help us to know whether or not we're going to cross the x-axis once, twice, or not at all. Okay. So let's take another look at those three examples that we had. And I believe I switched our example 2 out for something a little bit different, just so you can see what it looks like when the discriminant is 0. So in our first example, our discriminant was a positive real number, and we crossed the x-axis twice. Okay. In our new example, yeah, this is different than the one I showed you. You guys can plug this in yourself, and you're going to see that we get a discriminant of 0. Whoops, that was the same equation. Here is a new equation for equation 2 that actually is going to have a discriminant of 0. And since we did not solve this one, I will set it up for you. So our b is 2, and our a and our c are both 1. So b squared minus 4ac is going to be 2 squared minus 4 times 1 times 1, which indeed will equal 0. So this equation, if we were to solve it, we would end up with x equals -1. And when we graph this equation, it's a parabola that is only going to touch the x-axis exactly once. So knowing the discriminants really will help us when we get to graphing these equations, right? If our discriminant is a real non-zero number, we've got 2 places we cross the x-axis. If our discriminant is 0, we are only going to touch the x-axis at 1 point. And now for our third example, as you remember, we had complex numbers as our solutions, and indeed we never cross that x-axis. Okay. So In our third example, our discriminant was a negative number, so we never crossed the x-axis, right? That's section 11.2. Take your time, go ahead and look back through those, and let me know if you have any questions.